my dear friends, you have a combination of resistor and inductor, but in this case you have a switch which have 2 points. So consider this as point A and point B. Wherever you switch it, you complete a circuit. That wasn't the case in type 1, type 2, type 3. So let's have a look. What is the difference? It is mentioned steady state have reached before switching. Before switching means if I come at B, a steady state have reached. When I say about steady state, that means the maximum condition of that have already achieved. A maximum condition means when I am connected to point A, I have a voltage source, I have a resistance, I have an inductor. Steady state for inductor means initially the inductor won't allow the current, right? But at a particular longer time, it has to allow a current because the resistivity automatically will go down. So that means the inductor will allow a current. So will it be a short circuit? Will it be open circuit? Question mark. When I said inductor has to allow a current, the next thing should strike your mind, that means your loop should be closed. When I need to have a closed loop, that means I need to have a short circuit. So that is the meaning of your steady state. That means your inductor will be short circuit. So let's solve. At t equal to 0 minus 10. It will move to B only at 0 plus condition. So at 0 minus it is connected to A. So when it was connected to A, it has achieved its steady state. So your circuit will be in this format. Your resistance will be as it is. And your inductor, since it has achieved a steady state, so your inductor will allow a current. So when it have to allow a current, that means your circuit will be a closed circuit. So that's the reason over here it will be a short circuit. That's the meaning of steady state current. So let's find the current for this. Since it is a closed path, apply KVL, simple KVL for this equation. So you'll be getting 10 I of 0 minus equal to, the current enters into negative, so it will be C20. So I of 0 minus is equal to 2 amperes. That's your case number 1 which you got. So let's go for your case number 2, that is at t equal to 0 plus 20. In the above 3 types, none of the parameters have achieved a steady state. But in this, it was already mentioned that before switching, the parameters have already achieved a steady state. That means the inductor will allow a current to flow. So you have already calculated whatever the amount of current which is flowing through inductor is 2 amperes. So let's see what happens at t equal to 0. When I say t equal to 0, that means switch is switching from A to B. So your circuit will be 20 ohms, 10 ohms. So whenever your inductor achieves a steady state, so at t equal to 0, you never draw an inductor or you don't short the inductor. You, instead of that, you draw current source and put the value obtained from case 1, which shows you what was the amount of current flowing across the inductor. Because you had short circuited, that is the amount of current flowing across the inductor. The value was nothing but 2 amperes. The reason downwards because the current I of t in first case was taken clockwise. So that's the reason even this circuit will have a direction downwards. So if I need to find the current in this, I cannot apply a KVL because everything is not voltage. So straight away you'll get the value of current. So I of 0 plus is equal to 2 amperes. So please make it a point, whenever you have an inductor in steady state at t equal to 0 minus, so if t equal to 0 plus, you will always draw an inductor with a current source. So let's go for at t greater than 0 plus condition. So at t equal to greater than condition, your circuit will look in this format. At t greater than 0 plus condition, your circuit will be at B. So you have 20 ohms, you had 10 ohms, you have an inductor because nothing you can remove it, you have an inductor, but since your inductor was in steady state at t equal to 0 minus, so at t greater than 0 plus, you draw a current source parallel to the inductor having a value which you achieved is your vacuum. So that is something different which you get. So this at t greater than 0, you'll only draw a current source parallel to inductor only when your inductor has achieved a steady state at t equal to 0 minus condition. Neither you won't be drawing any current source parallel to inductor at t greater than 0 plus. Okay. Now let's apply KVL in this format. I of at the resistance you will be getting 30 I of 0 plus the voltage across inductance. The formula is L di by dt. The value of L is equal to 1. So di 0 plus upon dt is equal to 0. No voltage source. Apply KVL to this part. So I need to find di by dt. Let this equation be A. So di 0 plus upon dt is equal to, shift this side, so it will be minus 30 I of 0 plus, put the value of I of 0 plus, so the value which you got of I of 0 plus is nothing but 2, so the di by dt value which you will be getting, my dear friends, in this case will be di upon dt 0 plus is equal to, it will be minus 60, the unit will be amperes current per time, so that will be the value for di by dt. So you had also been told to find d square I upon dt square. That can be only be obtained from an equation where you already have di by dt, and especially the equation should be written in such a manner that no value should be put into that. For example, I of 0 value should not be put into that equation. So in this case, the equation which you will be have named as A, so you will be differentiation equation number A, and the equation which you will get after differentiation will be 30 di upon dt plus it will be d square I 0 plus upon dt square equal to 0. So you need to find d square. So d square I 0 plus upon dt square will be equal to minus 30 di 0 plus upon dt. Put the value of di 0 plus upon dt square, it will be minus 30 into 60. So value which you will be getting for d square I upon dt square will be minus 1800. The unit you get is ampere per second square. So that is the logic you'll be getting. So let's have a few more examples on different type of different combinations, and let's go for type 5. Thank you so much. Signing off.